So let us quickly recall what last time we did. So last time we discussed, so we have a frame like this. And we have a particle which had a mass of m, and this mass m was revolving around this circle. So we defined a vector r of t, where r of t is the position vector of this mass m. So our problem is that we want to find this r of t. Okay, so we need to find this r of t, and the relation which will exist between r of t and maybe the dynamics itself, that we call as equation of motion. I told you last time that this equation of motion or the like r of t position ahead, we don't know these things. So we need to get that relation, and we go backwards. We find acceleration, and then we integrate acceleration to get the velocity, and we integrate the velocity to get this position. So similarly we did last time. I will not go in full details because last time I have already done this. So let r of t is xi plus yj. Then I told you that since this is moving on a circle, so if we take this normal vector which was making some angle theta with the x-axis, so our velocity, so velocity of this particle p will be in that direction, that is in n direction, and there can be any magnitude of the velocity, that is the speed, which we will see what this can be, or maybe it can be some any random value. And then we calculated this n. This n was basically cos of theta I plus sine of theta j. And we calculated that, if you remember, that we wanted to get the relation of this n in terms of this x and y, and we found out that this theta was something equal to tan inverse x upon y. I think it was negative, so something like this. So what next? So what we want to do today is that we want to simulate this particle. That is, we want this r of t to plot with the time in the Matlab. So what we are basically going to do, we will find this x and y as a function of time, so that when we vary the time, the x and y will vary in such a way that the x y point will lie on this circle. Okay, so how we will do in Matlab? So in Matlab, how we are going to do it? Okay, so how we will code this thing. So this is a very basic, but this will be like every code will have a same structure. Okay, So what we did here is that we calculate this velocity, which is nothing but dr upon dt, and that is this cm, and we will integrate this, and that will be our r of t. Okay, so r of t is nothing but integration of cn, where n is this and theta is this. Okay, so let us now start. So you know, for integration we need the initial condition. So what we will do is we want to integrate this system for some time. So first we will define time. Okay, t end. So maybe we will define it. So we will define what is our t end, maybe 10 seconds, let's say. And then what we will do is we will create a, for example, a time steps in steps from 0 to 10. So there will be a time scale from 0 to 10. Okay, so there will be a time scale from 0 to 10, but how many steps will be there? There will be 100 steps. So if it is 0, then there will be 0.1, then there will be 0.2, 0.3 seconds, 0.4, 0.5, up to 10 seconds. Okay, or there will be 100 steps. If you write here 1000, then this time will get divided into 1000 steps. Okay, so this is the second step. And third step, what we will do is we will define the initial condition. We will define the initial condition. First, we define for what time we want to integrate the system. In second, what we do is that we break this time into steps: 0, 0.1, 0.2, so on up to 10 seconds. Okay, this is what linspace does. Okay, I will also, when we will go to Matlab, I will show you like what this linspace does. But here, like this is what it do. So in initial conditions, what we will do is we will define the initial position, that is at time t equal to 0. What is the position this mass or this particle m started? Okay, for example, it started from here, so that will be our r naught, that is r of 0. Okay, and this will be some x0 I plus y0 j. Basically, there will be some x at time t equal to 0, that will be x0, and this will be y0. So we have to give these two things, x0 and y0, which will determine our initial position. Okay, and so this is our initial condition. Okay, and then what we will do? Okay, then we will integrate this thing. For that, what we will use, we will, so we can generate our own integrator, but at this instant of time, I will not like make that coding, because uh, when the time will like go and you will proceed in your course, you will be familiar with what is going on. So at that time, I will show you how we can build our own Runga-Kutta, or maybe Euler method for integration purpose. But at this time, we will just use what is there in the library, Matlab library, that is ODE45. There are other versions also, but let's take this ODE45. It will work good for us. Okay. So we will use ODE45 to integrate this velocity. Okay, so there is this velocity. We will use this ODE45 to integrate that. But for that, we have, so ODE, what ODE will use? ODE45, how it works. So I will rub this part. Raise your hand if you allow me to rub this. Should I rub? Okay. So how ODE45 works? So we have, for example, let us say we have dy upon dx. See, dy upon dx. Let us say that it is some function of x. Maybe it is equal to x square. Let us say that dy by dx is, let us take simple thing. Let us take it as x. Okay, let's take it as x. So what ODE45 will do, when you solve this function, that is f of x, you will give ODE45 this f of x, and you will give it this t time, that is the time for which you want to integrate this. So you will give, here it is not the function of time, it is the function of x. So you will give the x, I will call this as t span. Let me write this. Similarly, I will give it as x span. So for how much x I want to integrate this f of x function, I will give it that. And there are initial conditions. Yeah, very important. So I need to give initial condition for this y. And when I give this OD45, this thing, so it will return, it will give me. So what it will give me? It will give me the value of y for this span of x. For example, for first value of x, it will give me what is the value of y. Or if for second, what is the value of y. For third, what? So for whole set of x values, that is x1, x2, x3, so on up to xn, it will give me corresponding values of y1, y2, y3 up to yn by integrating this differential equation. Okay, so this is like how ODE works. Behind the scene, what is going on, that is, I have already told you. I will show that, not in this class. We will, but definitely we will do that. Any question from this part? One thing I want to add, that you can also join the Teams link on your mobile, because I think it becomes little bit difficult for you to go to like the laptop and click on and then ask questions. You can also join from your mobile, and when you have question, you can ask me directly from. I think you have. I have sent the link. Yeah, but even then, if you have any question, you can raise your hand and I will stop. Okay, so this is the setup. So here what we know is that we have this velocity, which is nothing but dr upon dt, and which is some c times n. Okay, so we need to integrate this thing. So this is same like dy upon dt. Consider this r, in the previous case this is y, and here instead of x it is t. So dy upon dt is some function. So this is our f of x in the previous case. Here, in general, I will call this as f. So this is our function which we need to integrate. And what is our variable here? So t is our variable, and what we need to integrate is this r to get the value of r. So instead of y, we have this r. So next thing is that you will write this function somewhere where you will calculate this f, and you will feed back it to ODE 45 to integrate it. Okay. So once this is done, then what we will do, so we have got this function here. Okay, we have got this function, and I call this function as this f function. I call it as my RHS. Okay, because my teacher used to call it as my RHS. That is why I call it as my RHS. So okay. What next? So we have ODE 45, and we have given it that function which is nothing but c times this, and we have given it the t span, that is the time for which we want to integrate it, and then we have also given it the initial condition. Okay, and some other stuff I will explain it. Okay, and it will return us what? It will return us, so there are 100 time steps. You remember, if you remember from here, there is time from 0 to 10, but this time interval has been divided into 100 steps. Okay, so there are 100 steps of time. So there will be, corresponding to each step, this OD 45 will return us the value of R. Okay, so there will be R of 0, that is initially, then there will be R of 1, then there will be R of 2, so on, there will be R of 100. Okay, R does not mean R the position at the 100 seconds. It means position at the 100th step, time step. Okay, that is our t equal to 10 seconds. So t equal to 10 seconds is something else, and these divisions is something else. So this 100 represents, it doesn't represent the time, it represents the time step. Okay, so this OD 45 will return you this thing. But what is actually this R of 0? If you see, this R of 0 is x0 and y0. Similarly, this R1 is x1, y1. Similarly, this is x2, y2, so on, x100, y100. Okay, so you have got this as a matrix. This is a matrix. This is 2 cross, sorry, this is okay, I think I should okay, it depends upon like how you, if you take like this, then it will return you like this, but it can also return you this matrix as like this: x0, y0, x1, y1, so on, x100, y100. It doesn't matter whether it returns like this or this. It depends upon the coding. I will show you. In my case, it will return like this. Okay, so this OD45 will give us this matrix. Okay, okay, let us consider that it is giving us this matrix. What is the next step? Next step is to get all the x, okay? And I have already told you that if we have a matrix and we want our entire row, we can get the entire row. How? So we want this first row. So x will be equal to this matrix. Let us call this matrix as solution matrix because this is our solution. So our first, no, not. Should we call it as a solution? Okay, let's call it as. So this is a solution matrix. So our first, this row will be equal to solution. Okay. First row. So 1, comma, colon. So when you write this thing, it will give you the whole row. Similarly, this all the y's will be equal to solution 2, comma, colon. So you get all the y's. Now what is the, so you got all the x's, you got all the y's. What is the next step? We need to plot. Now we have at each step, for example, at t equal to 0, we have the x and y value. At t equal to 1, we have this value. At t equal to 2, we have. At t equal to 100th step, we have the values. Now the only thing is that we need to plot these values. Okay. So for that, we will use a plot condition, plot command. Okay. So where I will write. Okay, I think if you are noting down it, then it is okay. If not, it will be available. So I will rub this. So next, what I will do is, so I have all the x, that is array of x, and I have also array of y values. What I will do is I will plot x and y. So this is x-axis and this is y-axis. When I use this plot condition, you will see a circle will appear. Okay, but that doesn't mean we have animated. It is just we have plotted it. Okay, there is a difference between animation and plotting. So we have plotted it and you will get the plot. But for animation, what we will do, we will at each instant of time, we need to plot the mass, that point itself, and no other point. So we will use the same thing, that is plot. We will use the same thing, plot. But what we will plot, we will not plot all the points. We will plot only x of some time, and we will plot y of some time, which are already given. We know at any time what is x and what is y. I will show in the code how we can do this, but this is the procedure. Okay, any question till now what I have said or tried to explain? Because now we will shift to Matlab and see how it works. Any question? Yeah? No question? Should we proceed to Matlab? Yeah. You can raise your hand and say, yes, we can go to Matlab. Okay. So is my screen visible to you? Is it visible? Can you again raise the hand? Okay. So this is a code which I have written for you, which shows like what I was trying to make you understand how we can code it. Okay. So first is this. Okay, let me first tell what this close all. So close out what close all usually uh, does is that if you have any figure command which is already there, for example, if I see my, okay, there is no command, but there might be like you are running the MATLAB code and already there is some figure. So when you will run the code, you will get new figure, but there will be also the previous figure. So to close all those previous figures, we use this command close all. And then CLC, what CLC does is, last time also I told you, this clears anything which is in this command window. Okay, so it will clear it. Why? Because if there is, for example, some error or some warning, that will get displayed here. Otherwise, you will not be clear whether this warning was from previous one or it is from this one. Okay, so we use this clear CLC. And then there is this clear all. This clear all command, what it does is it clears this workspace, which is this workspace. It will clear it. What otherwise what will like happen is that if we don't clear this this workspace, so some values of some variables which are previous one, they will get used in this. Okay, so we want we don't want any such value to be used in this program. We want everything to be cleared, and then whatever we are doing now, that should be like that should be there. So now let's start. So it is better when you write any code, you write your name and your institute's name and put a date when you start writing the code, and then write what the code is all about, like what is the title of the code. Okay, for me, like it is particle in a circular path. And okay, I am let me remind you that since I am present in this screen, so I am not able to see you whether you have any question or not. Maybe you will raise your hand, but I can't see you. So if you have any question in between, you can come to the like microphone, open it and ask me. Okay, otherwise I will keep on running and thinking that you have no question. Okay, so first thing is this T end. I told you that this T end, what it does is that, okay, let me first run this simulation and so that you can see what we are going to do and what will happen. Okay, so you can see that the particle started from here and now it is going around a circle. Okay. So was the simulation visible to you or not? Yeah, okay. So this is our like today is what we want to do in from now. So okay, let's proceed. So you can see there are two figures. Okay, already there are two windows open which shows the figures. So if I don't, this shows the path and this shows the animation. If I don't use this close all command, these will not be closed, and when I run again, these will appear and the new ones will also appear. That is why I use this close all. So it is a good practice to write these three commands at the top of your program. Now the second thing is, for what time you want your code to run. For example, I want it to run for 15 seconds. So this is the total time. Okay. Uh, and then there is this animation speed. So I can increase the animation speed. I can decrease the animation speed. And this is, I will use, this is not just like I will write here animation speed is equal to 1 and the animation will run with one speed. No. We will see. I have done a code for this which will increase or decrease the speed. So if I write here 10, So it will make the simulation speed 10 times faster. Okay. See, it has already completed because the total time was only 15 and the speed was 10. So it took only 1.5 seconds in real time. Okay. But if I increase, for example, let us take 150 seconds and again run. So you can see the speed is very high because I have make the animation fast. Okay. So these are not the things I want to focus, but this was just like to say what these are, what these are going to do for us. So T end represents the time for which you want to run your simulation. Animation is speed, like how fast you want to run your animation. T span is something in how many steps you want to divide your time. Okay, basically you create a row vector for this time. So this T span basically is a matrix, a row matrix. Uh, from 0 to t end. I could have also used it as like this, linspace 0 t end to 1000. Okay, both of these can be used, but I have used here t span 0 to t end, so MATLAB will automatically break it down into steps. Okay, like ODE 45. Sorry, not o. So I will give this t span to ODE 45. That will all like automatically break it into some steps and give me the corresponding values for the x and y. Okay. So next is initial condition. So we have defined the time and we have defined the t span for which we want to integrate it. We want to integrate it from 0 to t end, that is 0 to 50. Now what is the initial condition? So where is your particle initially? So our particle is at x equal to 0 and y is equal to 1. That is it starts from the top position. If I put x0 y0, it means that it starts from origin. Okay, but it is like that. So what is c? C is 0.5 minus 0.5. Okay, this c is same c which I told you that the velocity or the speed is some c times n hat. This is that c. Okay, and then if you have any confusion, please let me know, because it is your first time. I can understand not all the things will be clear to you, so it is a genuine if you get confused anywhere, so don't feel anything ashamed or something like that. If you understand this code, not this time, but after revising 2 or 3 times, so you will get a good hand on the this developing algorithm and coding part. So it is essential for you to understand each and everything. Okay, so this is that coefficient. Okay, so I am defining it as a C. So I gave a value 0.5 minus 0.5 to C. And then this initial condition, I put them as a single vector. I call this as Z0. Oh, I could have also write it as R0. It is not necessary to write it as Z0. But just that Z0 is a name which I have given to this matrix. And you should know that this matrix X naught, Y naught. So X naught is how much? 0. Y naught is 1. So it is a 2 cross 1 matrix. It is basically a column vector. Okay. So this is the initial position which I will give to ODE 45. Okay. So after this, uh, come to this ODE 40. So now I will be using ODE 45. Okay. So where is this ODE 45? There. So ODE 45 takes function. Which function? That f. For us, it was something like dr upon dt, something equal. So we have to first develop that function. Okay. So let's assume that we have that function. I will call that function as RHS. Okay. So This is that function. Okay. So let us go and see what this function, and then I will come back to this step and see how the OD45 will work.
So let.
Yeah. Any question, Abrar? Hello.
सर हम एक्चुअली डिस्कनेक्ट हो गए थे यहाँ पे, आप रिपीट कर सकते हैं थोड़ा जो आपने अभी बोला पिछले 2-3 मिनट में?
हाँ, अच्छा, 3 मिनट पहले आप डिस्कनेक्ट हुए थे।
लगभग 2-3 मिनट डिस्कनेक्ट हो गए थे।
क्या मुझे बता सकते हैं कि मतलब कहाँ से मैं वहां से शुरू करूँगा, मतलब
सर
किस पॉइंट पे?
सर हम थे तब जब आप क्लोज ऑल का बोल रहे थे उस टाइम पे, क्लोज और
क्या
क्लोज
क्लोज?
क्लोज ऑल का।
अच्छा, क्लोज ऑल और टी स्पैन वगैरह। तो इनिशियल कंडीशंस आपने नहीं सुना?
सर वो जब आपने 150 चेंज किया था ना, 150 और 10 जब आप बोल रहे थे एनिमेशन स्पीड्स का।
अच्छा अच्छा अच्छा।
वहीं से, उसी के जस्ट बाद से, उसी के जस्ट
ओके
बाद से।
ओके
यस सर।
ओके 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 ओके। So, okay, let me start from there. So, I was saying that, yeah, so we have this T end, we have this T span for which we want to integrate our system, that is from 0 to T end, from 0 to 15 seconds. Okay. Now we want initial condition for our system. That is like what is the position from where our particles start? Because in XY plane, there will be some point, and corresponding to a particular point in plane, there is two values of, there are two coordinates, X and Y coordinates. So that this is the initial condition, 0, 1. That is our particle starts from X equal to 0 and Y equal to 1. You can give any initial condition, but I have taken this as initial condition, okay? And then I am taking this C. C is that coefficient where I defined that vector velocity is C times n cap. This C is the same C. Okay, you can put any value. We will vary this later on, but at this time, just keep in mind that this is just a value I am storing in C. And then I am making this initial position as a vector. Okay, x0 is not a vector, y0 is not a vector. So I will put it as a vector, and vector has two components. So z naught actually represents the initial position vector, which has x component and which has y component, these two. So using these two, I have created a vector, which I will call as initial position, which is z naught. Now I will feed this initial condition to ODE45. Oh, okay, so this section will discuss how we are going to use ODE45. So for ODE45, I am giving this initial condition. See, Z naught is the initial condition, and I am feeding it to this ODE45 here, okay? And I also told you that ODE45 needs that function F. So that function I have defined as RHS. And what is this RHS? I will come to it. And what else it takes? T-span. And you have already defined here what T-span is, okay? So you are giving T-span. That is for what time you want to integrate. So our function, T-span and Z naught, these are three things which ODE45. And it also takes these options. I will also discuss this, but let's go first to this RHS function. So what is this RHS function? It is basically my RHS. So let us go and see what is this my RHS. Okay. So at the end of the code, I have defined this my RHS function. See, this is the way you can write your function. So what you have to write is, you have to write function and then the name of your function, then the like what you want to get from the function. So I want z dot. Okay, I want to get z dot. I think I should quickly tell you what I think I have not told you what this z dot is, because I think I was using this r and dr upon dt. Let me quickly go and tell you what this basically z naught is, because otherwise you will get confused. Uh, so is board visible? Yeah. Okay, so is the board visible now? Okay. So instead of using instead of using x, y, r and other stuff in code, I will write z. Why? Because sometimes there will be x, y, r, some other stuff will be there which I have to integrate. So I can't like keep on changing the name in my code. We will be writing so many codes, and each day I will keep on changing. Today it is r dot, yes, next it will be v dot, then after that it will be some other dot. So to avoid this thing, what I will do, I am defining z as x and y. Okay, so this z is basically x and y. So you can quickly get that this z is nothing but r. Okay, so this z is x and y, but x and y we know is r. Okay, so what will be the z dot? That will be dz upon dt, and that is nothing but dr upon dt. Okay, and we have already calculated that is c times n, our velocity. That is velocity. Okay, so this z is nothing, it is same as r, nothing, but it is only for the purpose of coding that I am using z instead of r. So z dot is what? It is basically z. So what we need to find? We need to find z, that is x comma y. What we are given? We are given z dot. So we will integrate z dot, which is basically dr upon dt, which is our function, that f function. We need to integrate this thing to get the z. Okay, is it clear? Or there is any doubt? Okay, I hope it is clear. If it is not clear, I think it will get clear once we do the whole coding. Let me again share my screen. Okay, so is the code now visible? Okay, so this z dot basically represents r dot. So we want to find that r dot. Okay, so whatever till now we did uh, was that we calculate that velocity. Okay, so this is our x. What is our x? Z of 1. Just like 1 minute ago, I showed you on the board that z has two components, x and y. The first component is x, the second component is y. That is what I am writing here. X is first component of z. Y is second component of z, where z is a two component vector. First component is x, second component is y. So z is basically a matrix containing two rows and one column. Okay, so this is how I can write it. Then if you go to your notes, you will see I defined that theta. That theta was tan inverse of x by y. In Matlab, we have a command known as a tan 2. So basically this returns you the tan inverse. For what? x by y. Okay, this is how we write it. Theta is equal to tan inverse of x and y. Okay, so I will provide this code. I will send this code to you so that you can run it at your places. If you have any doubt, you go through it once in the next class, or maybe in between you can contact me. I will again explain at that time. Okay, so theta is that theta which we define, and I is that I cap and j cap. What is I cap? It has unit along x, unit distance along x, and it has zero distance along y. So I have defined I as a vector whose x component is 1 and whose y component is 0. So 1 colon 0 will be a uh, column matrix. The first is 1 and the second is 0. Similarly, J is a J cap which has 0 component along x and 1 component along y. Okay, so it may seem to you that it is difficult, but believe me, when you will get used to it, it is very easy because it uses vector notation. Okay, I am not using any scalar thing. So you define a vector I, you define a vector j, and whatever equations you have wrote on your notebook, you have to just write those things in terms of Matlab. Okay, so first I define x, then I define y, then I define theta, because for theta I needed x and y. That is why I wrote x. And then I will define I, then I will define j. And now that n hat was there, which I called that unit vector, which was tangent to the r, or tangent to the circle, and that was something cos theta I plus sine theta j. See, exact equations I am using. I am not doing anything else, any other thing. Same equation, that n hat is equal to cos theta I sine theta j. Okay, now when we got n hat, then we already know that our velocity was what? C times n hat. See, I write C times n hat. Okay, and see, this velocity itself has two components, x and y. Why? Because n hat is a vector. It has two components, I component and j component. Therefore, this velocity is also a vector having two components, x and y, which is multiplied by this c. This c just uh, increase its magnitude. Okay, and then what is x dot? X dot is the x component of velocity. That is first component of velocity. What is y dot? Y dot is second component of velocity. That is v of 2. Okay, so we got z dot. Z dot is nothing but x dot y dot, because z is x and y. So we got z dot. So this is what we wanted from this function. So we have this my RHS function. We have defined this my RHS function. This my RHS function tells us, give us the time, give us the z, that is particular x and y, and give us this c value. Okay, I can define this c value inside. So let me okay, at this time. Okay, so give me this c value, give me this z value, give me this t value. I will return you z dot. That is, I will return you the velocity at that instant. Give me the position at a particular time. I will give you the velocity at the particular. So what does this my RHS do? It just calculates the velocity at a particular position in time. Okay, and we know that velocity was our f function. So we need to give this my RHS function to ODE. Now going back, so this my RHS, but there is a thing with ODE, that it can only handle a function which is function of time and the variable. There can't be anything else. So I need to convert this my RHS function as a function of time and z. That is why I am again defining another function as RHS, which is basically same function my RHS, but I am making it a function of t and z all. only. This my RHS was function of T, Z, and C. But when I define this RHS, it is now function of T and Z only. And I give this RHS to my ODE45. Okay, I think this is the toughest part which you need to understand. If you understand it, you can code anything. This is the basic algorithm, or we can say this is the general algorithm for any kind of coding stuff you do. Uh, any question till now, or should I proceed? Yeah. Any question? No? Feel free to ask questions. Why are you? Why should you like be terrified or something like? If you have any question, you can ask. If you don't understand some, see, if it took me 1 month to understand, how can you understand it? You may be more intelligent than me, but like if it took me 1 month, at least it can take you a week to understand. So there is every possibility that you might have questions. So you should ask questions. I will appreciate. Okay. So now we have this RHS function, and we have given this RHS function to our ODE. Okay, and we have this T span already, and we have this Z naught. Okay, now this ODE45 will integrate this function, that is velocity function, and it will give us the solution. So what will be that solution? That will be the X and Y values for whole amount of time. Basically, this solution saves X and Y value for whole time. Okay. But I already told you that OD45 will evaluate or divide the time by its own will. But maybe we want it to be divided in regular fashion. So what we do is we define our time row vector for time from 0 to Tn and divide it into 1,000 steps. We want to divide this time into 1,000 steps. Okay. And then we want our solution, whatever solution ODE45 has given, we want it to be evaluated at only those instant of times. Okay. So for that, what we use is there is a Matlab command which is known as deval. What this deval does, that it takes this solution from ODE45 and it evaluates it for only this T time. Okay, so you get your Z for your time T, like whatever time string you have. Okay, so now you have this Z value. And what is Z? Z is nothing but the X and Y values. The first row, which will be 1,000 values of X, and the second row will be 1,000 values for Y. So we need to segregate these. So we will write Z of 1 comma colon. This will give us the whole row for X. So this X will have how many values? 1,000 values. First value will represent the initial value of X. Second value will represent the second at what is the value of X at second instant of time, and then third instant of time, then fifth, then 1,000 instant of time, what is the value of X. So this X will store all those values. Similarly, this Y will store all those values. So if you go to workspace, you open this X. Okay, see. I have to. I think I am using this X somewhere else. That is why it is doing this. Okay, let me do one thing. Let me run only till this. Wait a minute. I don't need to. Okay, so let me run it only till this. So I will put a break here, and I will show you what this X is. Okay. So now go to workspace. Here you can see 1 cross 1000. So it is saying me that this X is a matrix. And what kind of matrix it is? It has one row and it has 1000 columns. So let us see how this X is. See, this is I have opened the X. So at X at t equal to 0 or at t is equal to first time step, the value of X was 0. At second time step, the value is this. Third time step, the value is this. Fourth time step, the value is this. And at thousand time step, that is the at t equal to 15 seconds, this is the value of X. Okay. Similarly, you can check for y. Y is also 1 cross 1000. So we have got 1000 values of x and 1000 values of y. That is, we have got 1000 points on a plane. So if we plot all those 1000 points, you will get a circle. Okay, so let's do that and see. Okay. Wait a minute. So what I did, I plotted x and I plotted y and I got this circle. Okay. So how? For plotting thing, I use figure to get a window for figure. I called it figure 1 because I have another figure. So then what I do is I use plot command, plot, and then I use this x comma y. So it will plot my x comma y. And then I am using this dash. That is, I can also use like double dash. Let us do that and see what will happen. It will create a dashed line. And K is for black. I can use here blue. Okay. And then there is this line with width. It shows the width of the line. Okay, the thickness of the line. I can take it as 2. See how the code will now behave differently. See, now I have got the dotted thing. Okay. So I have this. Okay. So, but you can see that I didn't got the names for this x and y. So I can label x label. I can write, that is what is the name for x-axis. Okay. So I can write for x coordinate. Okay. And similarly, I can write uh, for, so I can write y coordinate, y label, y coordinate. Okay. And I can also add a title. So I can add a title for this, which will appear at the top of the figure. So I can write a title. Let us call title as circular motion. Okay. So let's see how the figure looks like. So you can now see circular motion has come as the title of this figure. X coordinate has come as the x coordinate and y coordinate. You can write anywhere. You can just write x. You can just write y. Whatever you want, you can write it. It is not like that. Okay. But this is only that you have plotted x and y. You have not animated it. Okay. Animation is yet to be done. So animation is something a little bit which will take a little bit more effort. Um, so I think the time is over. But if you want, I can continue if you are willing. If you want to me end it here, I can end it here. Otherwise, I can continue and show you how to do the animation. So what do you want? Yeah, what? Like I can't raising hand. What does it mean? So can anybody come and tell me whether you want to continue or should we continue in next class? What do you want?
So
Hello.
सर नेक्स्ट क्लास में ही देंगे क्योंकि स्टूडेंट्स भी कम हैं और हमारा टाइम भी सर अभी दूसरी क्लास है अभी इसलिए।
Okay. Oh, okay. Okay. Sure. That is why I told. Okay. Any question you have from anybody?
मुझे
Okay, I will send. Okay, okay, I will send this code to on Teams so that you can run on your laptop. Just run it and try to vary things and see how the things are going on. Okay. In next class, I will continue and show you how to animate it. Okay. But if you have any question, you do it. There may be some confusion or other. Whatever you have, you can ask me. Okay. Um, so. Um,